Hello everybody and welcome. My name's Susanna Streeter. I'm your moderator and hosting all of these seminars here today and tomorrow, talking you through all the exciting developments in the industry. So today is Architects Day at the Natural Stone Show, and today's seminar is Stone Laying the Foundations of a Sustainable Future. Now this has been organised in collaboration with the Stone Federation of Great Britain and Natural Stone Specialist magazine. So we're going to begin with the what, why and how of environmental product declaration. So these really do help specifiers compare the environmental impact of different construction products. And the Stone Federation has been working in really close collaboration with One Click LCA, Life Cycle Assessment, which enables companies to produce EPDs in a matter of weeks using this one-click pre-verified EPD generator. This is an automatic tool which can develop some pretty robust EPDs to comply with all of the standards. So the aim is to provide evidence of just how low the environmental impact of stone is. Of course, the stone we dig out comes almost exclusively from the top few tens or sometimes hundreds of meters of the deep rocky crust on which we live. Now, it would take millions of years to dig up all the stone, and what the industry does dig up is simply sawn and shaped, so eminently recyclable in its original state. So that's what it means when we say stone is sustainable. The trouble is it can be really difficult to determine the true environmental impact of products used right across the industry. I mean, the manufacturers of really high carbon products tend to concentrate on the percentage reduction of carbon that they have achieved rather than explaining just how much CO2 actually resulted from the production of their materials. For stone masonry, the carbon content might be as low as 1.5 kilograms per cubic metre. And some of that, of course, comes from the electricity used in sawing and working stone. And as electricity generation increasingly, as we know, moves to renewable sources, that is going to continue to fall. Likewise with transport. Transport obviously absolutely key for the industry. But despite all of this, it is really difficult for specifiers and those people working in the industry to really work their way through all the background noise in order to compare the true carbon nature of a whole variety of the products they use. And that is where environmental product declarations come in. That's exactly what they are intended to address. So this document is intended to communicate really transparently the environmental performance or impact of any product or material over its lifetime. And in the construction industry, EPDs support carbon emission reduction by making it possible to really compare the different impacts of different materials and products in order to select the most sustainable option. So this is what we're going to be talking about in this session, and I'm really excited to say we've got a host of experts in this field to tell you more. So we have Dr. Flavie Lowres, who's a consultant with the company Green Thinking. She's promoed here on the screen, as you can see. Also coming up, we'll have Lynes, Associate Director of Engineers, Webb Yates. And Sini Laine, I'm pleased to say, is here. She's the Executive Director of KIVI, previously known as the Finnish Natural Stone Association, and it's already produced EPDs for Finnish stone. So all really, really well placed to give you a lot more detail about what all of this means. So let's kick off by welcoming up Dr. Flavie Lowres with EPDs Explained. Take it away, Flavie. Thank you.
Thank you. Good morning. Thank you very much for the introduction. So yes, as you say, this session is all about EPD, and so I thought I'd start by giving some basic principles about what they are and how you do them, and also the importance of getting them done. So we talked about the environment. The Paris Agreement was signed. We're all aware of it. What it means is that really we all aware we need to reduce our carbon emissions roughly by 50% by 2030 in order to achieve the targets that we set ourselves and to keep temperatures below the 1.5 degrees rise. And that's led to multiple responses. In the UK was the first country, first government to respond to the Paris Agreement and to the climate change challenge by making the signing the UK Climate Change Act, which was revised in 2019 and now says that we have to reduce our emissions by 100% by 2050, with some milestones along the way. Challenging targets, but very important. What's really interesting as well is that recently local authorities have responded very strongly to the climate emergency. Some figures show that 75% of local authorities have declared a climate emergency and made some pledges to reduce CO2 emissions by 2030, 2040, 2050, but to become net zero. What that means is sometimes yet to be defined, but those pledges are here and I hope that we can honour them. The construction industry, on the other end, has got a big role to play in order to reduce the CO2 emissions for the UK and for the world in general. Because if we look at figures, they are huge. It's a massive industry, we all know it, but on average, we think that they're responsible for about 50% of all resources extracted. They produce about 30 to 45% of all waste produced in the UK. If we look just at the carbon footprint associated with just the products, the construction products, it's about 11% of CO2 emissions for the UK. So we're talking about big impact. It's a big challenge, but at the same time, it means that we can have a very big influence, and it's important to take that carefully. Some of the reasons is because we keep demolishing, we keep rebuilding. The urban environment is rapidly changing. Buildings are not lasting as long as planned. Products are not staying in buildings as long as they should be. You could have a product that's got a service life of 60 years, and yet they're being taken out because of fashion, because they don't look like they should, the feel that the client wants anymore. The industry response has been very strong as well, and I actually believe it's even stronger than the UK pledge, because apart from the pledge that they've made to reduce CO2 emissions, there's been not that much done so far in the UK in order to implement some of this and targets. Then, if we look at the commitments that was made through the Better Building Partnership, which they've created the climate commitment pledge. They had 37 signatories from companies that cover 11,000 plus properties. They include the clients that I've put at the bottom, but that is just a few. British Land, Aviva Investor, Cadogan, Canary Wharf, massive portfolios. And what they've pledged for is to look into reducing emissions. And they've explained in here some of the basic principles on how they want to go ahead. But the overreaching objective is to deliver net zero building by 2050. And they want to look at those in terms of both the operational impact and the embodied impact. Now, the embodied impact is the impact related to the extractions of raw materials, the manufacturing, transport of the materials, installation, use, and etc. So this is the reason why we're here today. This is the one that concerns us. And then going further, you look at clients like Grosvenor's, for example. They've published their Think Zero, their Pathway to a Better Future document. And what they have done, which I think is quite interesting, they've made some commitments at different stages. For example, in particular, they've said reducing the embodied carbon of development and buildings to become operationally net zero by 2050. Now, they have actually set some targets on the embodied carbon of the development to be below 500 kilograms per meter square. So that's quite ambitious, it's very specific, and they need help from manufacturers to help them to kind of reduce. The UK GBC published in, I think it was 2019, the framework to define net zero carbon buildings. What they define it as is 2 stages. It can be net zero carbon in construction or net zero carbon in operational energy. So the construction stage goes back to the embodied carbon, okay, to the impact created by the manufacturing, extraction, manufacturing, and use of products, and the construction stages. But what is very important is that it says it's about reducing construction impact, it's about reducing operational energy demand. Then you add renewable energy in order to provide electricity to the buildings, and then you offset the remaining carbon. But I think this is really important to emphasize the fact it's all about reducing, reducing, reducing. Now, there are many different initiatives in the industry at the moment around embodied carbon, but one that is quite important and that will really start to change and have an impact on the industry, I believe, is this UK net zero carbon building standard that's due to come out towards the winter of this year, so end of 23/start of 2024. It builds very strongly on the UK Green Building Council framework, but will add also some targets. So there are already some targets that exist on what good looks like, but we know that targets at building level on embodied carbon are very hard to achieve because there's not been that many studies, although they're starting to be more and more. And the figures that have been published so far need to be refined. So that's what this group is doing. But what I think is really interesting is the organisations that are involved into the creation of this standard. It's not just the UK GBC doing something, LETI doing something. This is the Better Building Partnership, which I mentioned before, big influence. It's about BRE, which owns BRIM, the Carbon Trust, RICS, REBA, and etc. So they're starting to become a real kind of consortium, kind of getting together to look at targets properly. Now, the one that concerns us today is about measuring embodied carbon. How you do that? There are some standards that exist. There are some standards at product level and at building level. At product level, that's EN 15804, which is also a BS, and at building level, it's 15978. They both work on the same framework of modular approach and presenting the information as shown on that grid. So what they have is the modular approach. So they've got different life cycle stages. A1 to A3, which is the product stage, which includes extractions, transport of the materials to the manufacturing and the manufacturing. A4 to A5, which is which are the stages of the transporting of these products to site. A5 is the construction impact, so what happens on site, energy, water use, but also waste generated. And then the B stage, B1 to B7 and C1 to C4, which are covering the end of life stages. Module D is often reported separately, and it's looking into the benefits and impact in the future. Now, according to the revisions of 15804, more recently, it's now becoming compulsory to report A1 to A3, but C1 to C4 and Module D. Okay, so all the EPD that are coming onto the market now will start to show all these different informations, whereas before they were only showing as a minimum A1 to A3. Now, the reason why we want to align the approach that is taken between products and buildings, and all the targets are at building level at the moment, but the relationship is that a building is made of loads of different products. So it's all these products put together and all this information put together that creates the impact at a building level. Okay, so when you start measuring an embodied carbon of a building, you start looking into the products that you might use, but it's tend to be done on a generic basis. So it's going to be some generic brick, for example, and this would be the data that will then be sourced in order to do the carbon footprint would come from generic database. So it's a stone, and those might be sourced through the IC database, for example, which is publicly available. But as the design evolves and the architects or whoever's doing, or the contractors, whoever's doing these assessments, they start to use more manufacturers. They will be seeking some manufacturers' data. So they will look into the information available. And at the end, they can start to build up a more complete picture with better information. They won't have EPD for every single product or product manufacturer specific data for all products, but they will start to kind of look into this information more and more. And those specific informations are sourced from EPD. Okay, there is really the currency that is being used for carbon footprinting of products in the construction industry, and done in accordance to the EN standard I mentioned here, EN 15804. So I just thought I'd give you an example of what an EPD looks like. You've got a front cover. You have what is very important on this slide is the fact that on the front cover you have an issue date and an expiry date. An EPD is valid 5 years, okay? After which it will need to be reassessed. But then it provides information about different life cycle stages that are covered in this EPD. It will provide a product description. Then you'll have some technical informations. The content will provide information about the content of the product, but it's not about kind of revealing all the recipe of the products. It's about kind of providing enough information that the user will have some ideas about what's inside the product. And it also has a manufacturing process flow diagram. Okay, so some very generic information, nothing that tells you how much energy is required to manufacture the product, so nothing that will provide issues for the manufacturers in theory. It's a bit like, it's called, an EPD is a nutritional label. It's a bit what you see on food packaging. Okay, so you can find the ingredients, but you cannot make the product again based on this information. And then you've got tables and tables of numbers, okay? In those tables and tables of numbers, you have the GWP value, and which is expressed in kilogram CO2 equivalent against the functional unit that's been defined within the EPD. And then you've got your stages A1, A2, A3. And the A1 to A3 is typically the value that is being taken. So there's one number in there that tends to be the value that is being taken forward for the assessments afterwards. However, you also have all the values for the A4, A5, and all the stages that you've done afterwards, depending on what the manufacturers decided to declare. Now, in order to get an EPD, you need to do an LCA study, life cycle assessment study. This is where you appoint an LCA expert, or you use a tool like One-Click LCA or Laine. You then collect a lot of data. So that goes to the manufacturers. There's no escaping this. Manufacturers need to provide a lot of information. The consultant or the tool will do some analysis of the results and produce a very complete result that contains. The report will contain a lot of information that have been collected, so it is a confidential report that is for the manufacturer. They use this report in order to fill up an EPD template, okay, which is essentially your unverified EPD at this stage. So you fill up a template, which is in order to produce the document in the format that's shown in the slides before. That EPD template, together with the LCA report, is submitted to a program operator who appoints a third-party verifier who will have to declare any conflict of interest and etc. in order to make sure that they can check that the information provided are correct. Then the EPD is published by the program operator who appointed the verifiers. The EPD is published on the program operator's website and also on eco platform. Okay, so the manufacturers can publish the EPD on their website, but I would always advise you to go back to the program operator's website to make sure that they are actually there, because it's their responsibility to keep this information valid. So where do you find EPD or program operators? You can go onto the eco platform website. There's loads of program operators listed there. As long as you pick one of those, you'll be fine. Where do you find EPD? You can go again on the program operators websites, or you can go onto eco platform, because eco platform is a international organization that is trying to create collaborations between program operators and recognitions that the EPD are of good quality if they're provided by these program operators, but they're also trying to create a big database of all the products. So you won't find absolutely everything, because this is still new, that it's become mandatory to publish on this platform, but you'll start, as time goes, you'll find more and more of those. The reason why you want to do EPD, in my view, is because there's loads of drivers. I've shown you some before, but contractors are really keen to get some and to start measuring the life cycle assessments of their projects. I've put here Wilmot Dixon, ISG, Morgan Sindall as examples. But you also have drivers such as, for example, the Construction Leadership Council published their Construct Zero program. The Mayor of London have published a London Plan Guidance, and it requires that you carry out whole life cycle carbon assessments. That's for the referable projects only, but still something that you have to publish at planning stage. But also BREEAM, and BREEAM has been asking for life cycle assessments for many years already. But things are likely to change, and I'm hopeful that we will start to see some requirements in building regulations. So there's this Part Z that has been discussed for a while, and there's been some discussions in Parliament last year and more throughout. And I'm seeing more consultations from government asking how much time it takes to do an LCA, and, how much does it cost, and etc. They are really starting to kind of asking questions to the industry, and I think it won't be long before we start seeing those in building regulations. So that's everything for me. Thank you very much.
Thank you very much, Flavie. It's really, really fascinating. Just before you go, I just want to see if anybody in the audience has any questions for Flavie. Just raise your hand. But while you're thinking about that, Flavie, just tell me, what would you say that EPDs really are targeted at?
So EPDs, the product manufacturers, but those that read them are the architects, designers, and probably the contractors who are seeking some credits into BREEAM.
And they're not mandatory, though, are they?
They're not mandatory. It's currently voluntary.
Okay. And would you say that needs to change?
I think what's interesting, what will change is probably that the regulation and request to do life cycle assessments at building level, which will start pushing the industry to ask more to the manufacturers. Whether you need to start mandating EPD, probably if you're starting to make some green claims. So countries like France, for example, when manufacturers who want to make green claims have been required to do an EPD to demonstrate those. Because I think this is the way to kind of start making sure that those claims are accurate, isn't it?
And then there's more confidence, and
yes, exactly.
fear of greenwashing fades away, hopefully.
Exactly.
Okay, well, Flavie, for now, thank you. If you've got any questions, though, for Flavie, you can pose them during the panel. She's going to be coming back later to have a bit more of a chat. But thank you very much for now. So now I'd like to welcome up to the stage Alex Lynes, who's the Associate Director of Webb Yates, and he's going to present the building professional's perspective on maximising the potential of EPDs. So, Alex, welcome.
Really amazing groundwork of exactly what EPDs are. You've really done the heavy lifting there. Thank you very much. So I'm a structural engineer, work for Webb Yates Engineers. We do a lot of work with structural stone, so load-bearing stone and slightly less load-bearing stone. But you might have seen some of our projects. I'll kind of flick through quickly. This is a close-up of a project in Clerkenwell Close in London, which is it's a six-storey office block. This is some work we do with some stonemasons we work a lot with, doing some post-tension stone slabs to make some benches as a kind of prototype and trial. And it kind of moved on to doing some pretty big work with staircases. So this is a floating stair, post-tension stone, all solid stone. A lot of understanding of the material goes into sort of putting this together. And then we've done some kind of larger scale prototype stuff. This was outside the building centre a couple of years ago as a kind of prototype prefabricated stone plank thing. So why do we as engineers like stone? I mean, it's surprisingly strong. It's very stiff. It's also incredibly low carbon. Of really the main materials that we build with, it's one of the lowest carbons that there are, especially when you start to look at the end of life as well, where timber starts to kind of have slightly bigger impacts when you're disposing of it at the end of life. So this is a kind of diagram of how much material you would need in order to support a weight. So you can see that you need a lot of timber, a kind of medium amount, a very small amount of steel, and then a kind of pretty small amount of stone. And then at the bottom, you can see the carbon that actually entails to support load. So this is not just looking at sort of 1 meter cubed of the product, it's looking at kind of how much of that product you actually need to use. And that's, I think, where stone really comes into its own. So the value of use for carbon here, I think, is a kind of reasonable estimation for the sort of stone that we're using. But one of the challenges that we come across is that stone EPDs can be very variable in how much carbon they say that amount of stone has. So there's a kind of a range that you might see. I thought this would be quite clear, but actually two of them are so much higher than all the rest of them that it's pretty difficult to see the range at all. The ones on the far right there are stone tiles and stone cladding, and then the rest of them are kind of more mass blocks of stone. So removing the other two, even the lower end of that scale has quite a big range between it. And the reason for that range is really how much processing that stone is undergoing. So the more processing you do to the stone, the higher embodied carbon it ends up. And the stone especially, this can be a massive difference between the lowest and highest amount. So understanding what you're doing to it and what product you're using really affects how much carbon you're embedding into your building. One of the other big reasons that stone can vary so dramatically is because it's quite heavy. You need quite a lot of it normally, and you normally need to transport that from varying different places. So this is the kind of range of how much embodied carbon it can take to transport a kilometre cubed of stone from different places. So on the far left, you've got kind of local quarry down the road, driving it to site, and on the far right, you've got stone coming from China that's going overland, which is sort of very unlikely to happen. You're more likely to be shipping it, but you can really see the range of impacts that your choices can make. So this is really where it becomes important to drill into exactly what stone you're using, where's it coming from, and how you're processing it. This is a little bit different than from many materials where you're more concerned with just, it's this material, it's normally coming from pretty locally or within Europe at least, whereas with stone, depending on exactly what type of stone you're picking, it can come from very far away and be very highly processed. And that can kind of lead to this sort of range between the two. So on the left there, you've got the kind of local natural stone used as a kind of walling material. And on the right, you've got sort of a China stone from China that's been shipped overland, highly manufactured, highly polished into a thin cladding tile. You can really see that there's kind of orders of magnitude of difference between the two in terms of the carbon that's embodied in that material. So kind of where does the massive difference come from, and why do we have that giant difference? So the kind of manufacturing of stone seems like it should be pretty simple. You've got a quarry, you quarry stone from there, you take that to a stonemason or a processing place, and then you take that from there to site. And in fact, kind of mapping this onto the life cycle modules that we were just talking about seems relatively straightforward. You've got your quarrying, that's A1, transport from quarrying to the manufacturing place, A2, stonemasons, A3, building on site, A4. Seems to map very nicely. But the problem is that actually a lot of processing happens at the quarry. So you end up with a couple of different places you might be doing stuff to that stone. You might be cutting it to one size block and then shipping it to somewhere else, cutting it to a different size, shipping it to somewhere else, and then polishing it or finishing it. And that means that actually the life cycle stages get a little bit more messy than a lot of materials where it's a bit more straightforward. And at the end of it, the manufacturer is selling a product. And the reason for that really is that stone isn't a product, it's a fundamental material. What you can do with it is kind of massive and ranging. So I started trying to sort of plot out the different types of ways that you can process stone and why this diagram gets a bit complicated. So obviously at the quarry, it can be cut out in a variety of different ways, and I'm sure I'm going to miss a whole bunch of them here that I'll get told off for later. But you can cut it out in many different ways into many different sort of scales of product and type of product. Those that can then have a secondary processing normally to cut them into more of the type of size that you need, and this starts to get a bit more complicated depending on exactly the path you're taking. This can also happen at the quarry, or it can happen the secondary place, or a third place, locally onto your site even. And then it gets even more complicated when you start to look at the types of products that we're ending up with. So like this is just a very small, what I could fit on the slide, list of the types of products that you might end up specifying. And really the path of manufacturing to get to each of these products can vary wildly. The waste I've kind of put at the bottom because a lot of the waste in stone is actually then recycled and crushed and used as aggregate or used as dust to create manufactured stone. There's a lot of sort of circular bits within this, which is all really great, but it's a little bit more complicated than you first kind of would imagine. So what does that mean for EPDs? Sort of what do the EPDs say? This is one from Portland stone, which is actually a pretty good EPD, as I'm about to say the things that are a problem with it. I think this is pretty widely available and is a BRE verified EPD. It's for, 1 meter cubed of Portland stone is the description of what it's for. And then when you go to sort of the manufacturing process description, it gives you a relatively in-depth but quite vague in some ways description of the processes involved in creating this EPD. So it's kind of listing all the things that could potentially happen to stone in order to then come out. So it's saying things like it may also need to go to secondary masons for hand finishing. It may need to be chiseled. It may need to be checked. It doesn't kind of say exactly what this EPD is for, whether it's for a tile or a piece of stone, or it's a block, or whether it's for a really handcrafted sculpture. The photo in it is actually this as well, which looks pretty intensively made and pretty detailed, but it's kind of unclear whether it's exactly this. And I think even in a facade like this, the carved frescoes in the middle there are probably going to be quite a big difference between the carbon embedded in them and just some of the standard walling blocks that have very little sort of decoration added to them. So that's kind of one of the issues that we're kind of coming up against. So kind of how do we solve this? What's the kind of next steps here? Well, I think one of the things really is better understanding of how stone gets from the ground to site by the specifiers, the designers and the clients. Often it's kind of a black box. You're buying a product at the end of it and you don't think about kind of where that's come from. And we especially don't think about how much carbon has been embodied in that process in order to get to that final product. So this is kind of from the client and designer side of not just ignoring the whole process and thinking, great, I get a shiny thing at the end. It's talking to the manufacturers, talking to the quarries, talking to the people selling the stone and saying, how has this come to be in front of us here? Where has it come from? How has it got here? I think the transport embodied carbon of stone is a big impactor as well. Often when we're talking to clients and architects about what stones they want to use, where it comes from is almost an afterthought. It's more sort of, well, we want to use this stone. And then we say, well, where does that come from? They go, well, we don't actually know. It came out of a catalogue, basically. So I think understanding where it comes from for stone is especially important because, as we were saying earlier, it's a big lump of the carbon that you're going to be spending on that product. A bit more clarity on the process included within an EPD. I think that EPDs for stone tend to be relatively vague and all-encompassing, whereas actually the range of products that a manufacturer or a quarry might sell probably vary quite a lot in their embodied carbon, but it's not really shown within that EPD. And a bit more of a breakdown of what process and measurement each product is offered. So this is kind of a link to the same thing, and it really links to the first one, especially of the more we ask questions of where does this come from, how is it made, the more that the manufacturers and suppliers will know the answers to those questions and say, right, well, this is exactly how it's made, and that maps to this specific EPD. And then, yeah, I think a willingness for clients and designers to specify EPD-based carbon limits as well. So there's links to what we were talking about earlier of doing whole life carbon assessments and requiring them as various parts of policy, but also for the designers and specifiers to be specifying and saying, look, we shouldn't be using a stone that's higher than this level carbon, because otherwise it must be coming from far away or being processed too heavily. I think that's on sort of the specifier side as much as it is on the client side and the product side being able to offer it. Yeah, and then I think, like we were saying, stone really has the ability to essentially be a zero carbon material. It should all be able to be made with electrical renewable energy, and so moving towards that as the future is kind of what we should be pushing for. Stone is one of those materials that is very kind of underused and understood, and we want to be pushing to use it in more effective ways, but also to manufacture it in lower carbon ways, which is something that probably hasn't been factored into a lot of the manufacturing so far, and I think will need to be in the future too. So yeah, I think that's
Great, thanks very much, Alex. If anyone's got any questions, please do raise your hand. But from what you're saying there, it does seem as though the EPDs still need quite a lot of interpretation. Do you think architects are willing to put the time in to kind of translate them?
I think a lot of them are, especially when they start diving into it and really understanding their materials, I think that it's just the barrier to entry to doing that is a little bit high sometimes, and you really have to be digging and properly asking the right questions and knowing what questions to ask. So I think at the moment they are willing to do that. It's just a very challenging endeavour, and it really could be a lot easier.
And if you are advising architects how to interpret them, what should they be looking at? What are the kind of red flags that you think perhaps the EPDs don't fully lay out quite so clearly? What should they be careful about?
I think it's watching out for very generic EPDs, ones that don't say specifically, here's the manufacturing processes that went into that, because they often are encompassing a whole range of products, which is not actually helpful because, as we've seen, it can vary so much between the higher and the lower ends of it.
But given the drawbacks, do you still think that they really do help in specifying a product?
Yes, definitely. I think that they help on both sides. They both make the designers realise exactly what they're specifying, and also the suppliers understand where the energy and the carbon is in their manufacturing. So they're definitely great tool.
Well, thank you. So it seems still a work in progress, but at least progress has been made. So Alex, thank you very much. And are you going to be coming back later for a bit more of discussion? Now I'd like to welcome onto the stage Sini at Laine, who's the Executive Director of KIVI, and she's going to be talking about EPDs in the natural stone industry with the experience of Finland. Thank you.
Thank you. Good morning to everybody, and thank you for having me here. My name is Sini, and yes, I'm from Finland. So this is now the dive into the everyday life of the stone companies, and I'm here to tell you how we did the EPD project in Finland. So quickly about me, this is my 5th year in the industry, so it's been a ride. And let's have a quick look at the our association. We are small. We have 67 member companies and organizations in Finland, and some thriving student members as well. Our member companies, they represent everything from the quarriers to the landscaping and construction stones to interior stones, and of course on the other end we have the memorial stones as well. We are a member of Eurorock, and already there was a mention about the Green Building Council, so we are a proud member of Green Building Council Finland as well. The actual EPD project in Finland, why we started it and how it actually went. So this is what we get every day from every channel that we face, and we know that this is reality already, and it's probably getting worse for us. And here's the culprit, the CO2, as we call it friendly, the carbon emissions. And this is the reason, the biggest reason why we decided to start the EPD project. So we already know that the building and construction sector is one of the greatest polluters in the world at the moment. So it's nearly half of all the emissions in a global level. So something we needed to do. So it was May 2019, and before pandemia, before the war, before everything, and everything looked fine and dandy. So our board of directors are a group of 8 guys, very, very bright and ready to go forward. So they made a decision that let's get all our member organizations signed up for this project. We need to have EPDs done in Finland so that we can compete with other construction materials. And we arrange first the instruction webinars for the whole organization of our members, and we try to really kind of tell why we are doing this, because everything well, already they were thinking about money and how much it's going to cost. So the reason we decided to do this was, of course, the fact that we need to be out there. We need to bring our stone products out there, and we need to tell how good they are. So we chose a partner during the summer 2019, and it happens to be was One Click LCA from Finland, and we decided to go for them because they were the biggest and the greatest at the time, and the consultant that was our designated to our project was really down to earth, no difficult words, no difficult charts, no nothing. She was really kind of, let's do this and let's do this properly. It's like, yes, let's do this. So what we did, we started in September that year, and we started to collect the data with simple Excel forms. And there was the first kind of question mark already, because our members were like, yeah, but what kind of data do you actually want? And of course, the data is rarely formed. Everything is really good explained in the forms. And you have to remember that you need to collect the data from the previous full year in order to get into this project. So there's your one challenge, data collection. But in the end, again, we had amazing consultants from One Click LCA, and we got the data collected from the members. And then we were kind of happy and heading for the actual counting part. So the year changed. We went to 2020 February, and the calculation started. And how we calculated our EPDs was that we got several values from different companies, and the calculation was done as a medium calculation of that data provided. So even though we had, for example, for curbstone, we had 7 different companies, we only had one result based on those 7 data sheets. Well, everything looked fine until we were ready to launch, and then March 2020 happened, unfortunately. And at that phase, we were already in a good position that all EPDs were done, and they went for the third-party verification. And yeah, everything went rather smooth at the moment, and with some minor fixer-uppers in the June 2020, we published our EPDs, verified EPDs, in the Public Information Foundation, that is a Finnish authority, but also in the ECO database as well. And these calculations are, of course, available to all. And here's the beef. What we already knew, but what we actually had now data to back up, was that we already knew that natural stone has really, really low emissions. And here you can see our top products that we did the EPDs for. So we started from the very beginning. We had one quarried granite block, and we started from there. And then the more manufacturing done, there was a rectangular paving stone, street labs, curbstones, solid staircases, solid stone wall. Then we had floor and facade stones differently. And then, of course, we had the countertops. And because some of our members do work in the memorial stone business, we also had an EPD for gravestone as well. And of course, these mentioned above are for granite, and then we had own EPDs for slate, and we had yard stone and facade stone. And as you can see, the more you start doing finishes to your stone, the more or the higher emissions you get. But still, we are very low compared to some other building materials that are in the market. The number is for kilograms of CO2 emissions per ton of stone. Right. And yes, our verified documents are here, and there was a mention that it's not mandatory yet, but in Finland there's going to be a law in 2025 that will kind of when you start building, you need to prove what kind of emissions that building is causing, down to every little bolt and nail and piece of wood that you are using for the building. But yes, now that we have the EPDs, it is a kind of standard that we can compare with the other construction products. It uses the same methodology. It is a kind of a common set how everything is reported, and it's not complete the same as we already saw one EPD, but they are using the same format, so pretty much the same information is there. And at the moment, we do know that in Finland, for example, public purchasing processes are already taking EPDs into consideration. So it's not based on the price anymore, but it's based on the environmental values. And key takeaways, this is a must. Without it, I can now only speak for Finland, but without it, you're pretty much out of the game. And what you need to do is to commit, of course, your management, your team, and your people to this project. And of course, as I already mentioned, the reporting is very important. You need to have it in order already, even before you start the project. And what we did with One-Click LCA is that we demanded a separate guide for marketing purposes, because when you start browsing through an EPD, it might be a bit overwhelming. And we are rather simple people in Finland, so we wanted to have it in a clear and also kind of marketing way to tell our EPDs. And we wanted to communicate that natural stone is one of the best materials available. And of course, communication is vital. So keep everybody updated what you're doing. And my final slide is the key takeaway. So the momentum is now for natural stone. There's no better chance to start EPDs than now. We know that we have a good product in our hands, and we just need to tell it to everybody. Some useful links in my presentation, and please connect with us. Thank you so much.
Thank you very much, Sini. That was really fascinating. Just do stay there a minute, because I'm going to invite the others up. I just want to ask, what would you say the biggest obstacle you faced in getting kind of industry-wide engagement?
Well, I'd say that the industry-wide engagement wasn't that hard to get, at least in Finland. There were some saying that, okay, this is just another report and you want money for it. And we said, no, this is something that you can win your battles against other materials. So that kind of made it clear that this is something that we have to do now. Otherwise, we are out.
Great, and they understood that pretty quickly.
Yes.
Okay, well, thank you. Do come up, Alex and Flavie, and take a seat. Do sit down.
Thanks.
And it was interesting in our preparation for this, we were talking about what various kind of industry commentators have been saying when it came to EPDs. And Steve Webb of Engineers, Steve Webb once said apparently Weetabix does more harm environmentally than natural stone, which is a fantastic quote, isn't it? I mean, Alex, what do you make of that? But in the light of what you showed on the screen there, the graph showing that obviously it depends on where that natural stone is sourced from.
Yeah, I guess Weetabix is a pretty similar product wherever you're using it, whereas stone can vary a lot more. Yeah, I think it really shows that it has the opportunity to be one of the main building materials, and we just need to relearn how to use it and relearn how great it is, I guess.
Okay, thank you. If anyone's got any questions, do just put up your hand. But in the meantime, Flavie, could you just tell me how do you think EPDs are going to fit in with things like the Royal Institution of Chartered Surveyors? So RICS is fairly influential, of course, and it has its whole life carbon assessment for the built environment. And you did touch on it. Do you think this is going to be a game changer?
Well, I actually, the other thing that the RICS Institute is doing is actually working again in partnership with iStrucke and ICE and BRE and Carbon Trust and Reban, etc., is to create a carbon database for the UK. So one of the big kind of discussions at the moment is what kind of generic data should we be using for the different products, as I say, for the early stage kind of assessments, and how do we then start reporting EPD in a way that, in a central location for the UK, so that the likes of yourself who want to do an LCA can then find the information that is relevant to the country. So that database is being built at the moment. It's called the Built Environment Carbon Database. And they're looking into just kind of creating the central point. So that will become the replacement or the complementary of the current IC database and all the different databases that exist, and start to provide a bit of harmonizations. This is where all the EPD will start to kind of get pulled into as well. And that will become the kind of the source of information that go then into the life cycle assessments that are carried out in line with what the RICS methodology that is being published, if that makes sense.
Yeah, it's good to hear. And so now, could you explain, you talked about how the industry did understand that it could be a game changer. Are they already seeing natural stone as a result of EPDs are replacing other materials in designs that ordinarily perhaps would have been chosen over natural stone?
Well, not probably yet. We can see not comparison with other materials, but we can definitely see the increase in demand of natural stone. So, for example, 95% of stone quarried in Finland is now going to Finland. So it's been used more widely than ever at the moment, and just because we have data to prove that this is a good product. So yeah.
So Alex, are you pretty excited by EPDs in a way? Do you think they're going to be a real benefit to engineers, or do you still think there's still an awful lot of work to be done to try and really crunch through all the detail?
I think they are a really great tool, and I think we need to be using them more, and I think that they'll improve with time the more we use them.
Okay, thank you. And finally, Flavie, I did note a little bit of an element of frustration when you're going through all of the kind of slow developments that we're seeing and the slow push from the UK government for changing kind of the construction criteria. Do you think we're on the cusp now, or do you still feel that frustration?
I know. I think the UK government is way behind. I mean, you look at your example that you gave of Finland, but France has already regulated for doing the embodied carbon of buildings. But what I think is really interesting is that in some countries that are at the forefront of doing the implementing regulations, that's pushed by the government. But in the UK, I feel it's very, very strongly pushed by the industry. And I think that there's actually a lot of demand. And we shouldn't just be waiting for the government to regulate anyway. Regulation is only pushing from the bottom. And we should be just kind of aiming a bit higher than that. So I think it's only a matter of time where everybody's asking for it, really, regardless of what the government is asking for.
Okay, well, thank you so much for all of your insights, Flavie and Alex and Sini. It's been really, really fascinating. We've got a break here now for an hour, but then we're going to be coming back, and 4 architects will be presenting some of their award-winning stone projects from around the UK and Ireland, and also we'll be presenting the Stone Federation's Industry Choice Award for the UK and Ireland's favourite stone projects. But in the meantime, if any of you are really interested in a guided tour of the Natural Stone Show with Eric Bignell, editor of the Natural Stone Specialist, please do stay behind, and we have mics that we can offer you, and you can follow Eric around, and I'm sure you'll get plenty of really, really useful insights. But do come back in an hour's time, and let's take this opportunity to give the panel a round of applause. Thank you.
Thank you.